The size and section ballast, like the stones of large size are not desirable, and maximum size as 5.1 cm is preferably, as interlocking of stones of this size is better than that of stone of a larger size. The best ballast is that which contain a stone varying in size from 1.9 cm to 5.1 cm with reasonable proportions of intermediate sizes. The size of the stone ballast should be 5 cm for wooden sleepers, 4 cm for metal sleepers, and 2.5 cm for turnout and crossovers. The section of ballast lay consists of depth of ballast under the sleepers and the width of the ballast layers. The depth of the ballast under the sleepers is an important factor in the load bearing capacity of uniformly for distribution of load. In America, the depth of ballast equivalent to the sleeper spacing recommended because of heavier loads and the closer spacing of the sleepers being used in the country. In India, the recommendations will given unnecessarily a thicker layer of the ballast due to the large spacing of sleepers being used. The width of the ballast layer is also important, as the lateral strength of track depend partly upon the quantity of ballast used at the end of the sleepers. The lateral strength increase with the increase in the width of ballast layer, but there is a limiting beyond which no useful purpose is serving the widening. The width of limit at 38 cm to 43 cm from the end of these sleepers are computed. All the lines are equal pressure of in ballast through which loads are in the shape of bulb. At simplicity purpose, the load dispersion can be assumed 45 degree. You can see in the below figure, it shows clear the view. For uniform distribution of load formation, the depth of ballast should be such a way that dispersion lines do not overlap each other. You can see here in that, see sleeper spacing, what that is years. So the pressure, the W, two W's means there are two wheel load which is acting on the sleepers, and that whatever the dispersion which is take place, that is in 45 degree, and it should not be overlap. That is the minimum depth of ballast. So sleeper spacing S equals to width of sleeper W plus 2 times the depth of ballast, that is dB. The next one is the track fittings and the fastenings. The track fitting and fastenings are the fittings required for joining the rail end to end, and also for the fixed the rails to the sleepers in a track. The functions of track fittings and fastenings are like rail fixtures and fastenings have the following functions: to join the rails end to end to form full length of track, to fix the rail to the sleepers.